All right, so let's look at this one, an evasion attack. So we're using the SecML library. And the thing about this platform, Colab, is you're in a Python environment, but if you put an exclamation point in front of a command, it'll execute it as a bash command shell command. So that's where you would install a new library and then you import it into Python. So this is the security ML library. And so here we'll get a data set consisting of 3 groups of points to sort. All right. All right. There we go. So you see we have 3 different colored groups to sort, and they overlap somewhat, so there's a bit of work for it to be done to sort them. All right, and so now we're going to use support vector machines that we talked about before. If you have dots that are separated, either of these lines would do, and so in support vector machines you choose the line with the widest road. And then it's completely defined just by these points on the edge. The others don't actually have anything to do with choosing the support vector. But in this case, of course, it'll do a support vector that does not 100% separate the dots, but accepts some violations, because these dots overlap to some extent. So this will make the support vector machine, which is defined up here as a C classifier. And here it's going to try various values of this C metaparameter, which determines how much you're allowed to have violations. So it's going to try a few parameters and choose the best one. And so it gets 98.8% success with the best one. And we can visualize the results. All right, and as you see, it does about what you intuitively expect. It draws these decision boundaries between them, and the only problem is there's a few dots that are classified in the wrong area, and that's why the accuracy is not 100%. So here's how evasion attacks work. You can have something trained to tell various animals apart, and then you can add a little bit of carefully chosen random appearing noise, which makes it look just the same to a human, but now the machine learning model will call this a given with 99% confidence. And that's the important weakness of machine learning models here. They do not think like us, and they do not process vision like us. So even though to a human this looks the same, the machine learning model has for some reason chosen to use some mathematical combination of pixels to recognize this, which are confused by this noise. So if you can train an attack knowing of the model it's attacking, it can design these evasion changes that are very small and hardly noticeable and cause that the machine learning model to make mistakes. So what we're going to do here is we're going to confuse the model at this job by just moving one dot, and we're going to determine how far to move that dot using a calculated attack, mathematically calculated to be most effective. So here is an evasion attack. Before, we did evasion yesterday. Well, we did poisoning yesterday by just changing the labels of red dots to blue, which is a very simple attack, but this is a more sophisticated attack. We're going to poison the training data. This is evasion. We're going to modify. Here's what the modification. We took one red dot and moved it up here. And that one red dot is enough. That moves it. And that's carefully chosen to confuse the model. And now you can run a test to see how much the performance of the model degrades under various attacks. So we're going to vary the maximum perturbation here. can see how much harm it does as you go through various levels of perturbation. All right. Yeah, I see you here, Anthony. I know you're there. Yeah. Yeah. Oh, okay. Good. Well, I'll just go to the answers here. You'll see you get a nice graph showing, it's 100% accurate, and then at a certain level of perturbation, you get it down to essentially chance. Because 33% is, of course, chance when you have 3 categories. So anyway, this is one simple evasion attack, and there's various versions of it to try. And you can see how effective it is. And so that's the first project I wanted to show you today. I'm going to stop this recording.